So welcome to Blueprint Callable. It's a lot more fun than it sounds. By the end of the video, we will actually be logging out not only the start location of our projectile, but also the end location to the console here, so that we can see not only where the projectile is starting from, but where it's going to. Let me just get that working. There you go. So it's going to be finding both the world space location, which we've already done, and the barrels location for all of the tanks. So I will see you in there. So this video on the surface seems simple. We already have the hit point, the end of our projectile flight. What we're looking for is to find the position of the start of our projectile flight, the barrel's position, because of course the projectile goes from the barrel to the thing it hits. Pretty simple, right? So in the tank aiming component that we have just been playing with, we're going to want a reference to a barrel, which seems simple enough. So let's think about how we're going to get this reference to the barrel here. Well, firstly, let's make a member variable so that we even have something to store the barrel in. Private. Now, what type is this thing going to be? Well, let's go look at the blueprint for the tank and see what we've got. It's a static mesh component, the barrel. Okay, so for now, it's going to be, just use that. It's a static mesh component. We don't have a C++ class for the barrel yet. We may do later if it has some properties we want to add to it, like how far up and down it can move or stuff like that. But for the moment, we don't have that. So we're going to deal directly with the static mesh component. So let's just take a quick look at where this is in the class viewer. So remember, I'm afraid on a Mac you can't show anything but actors, but there is a way on the web. I'll show you in a moment. But for the PC guys, let's untick actors only and type in static mesh component. There it is. And you can see that inherits from mesh component and so on up until you get to actor component. So if we just collapse everything, you see these top level classes here, of which you only get actor when you have the actors only filter on. What are these? Well, let's just dock this on the right and pop to the web. Let's have a search for static mesh component, UE4, that'll do. And if we can find the right doc, which is the actual API reference, let's see, I think it's this one. That's the one. And then you get this inheritance hierarchy, which shows you what we just saw, that static mesh component ultimately comes off actor component. You see how that relates to mesh. Let's just expand that out here, actor component. The question is, very briefly, what is above actor components? Because we need to know how to find the static mesh component. Is it U static mesh or A static mesh? Remember, the Unreal coding standard says that actors, classes that inherit from U object are prefixed with U, and classes that inherit from A actor are prefixed with A. Well, is it an actor, a U object, or what? Well, you probably know that it's a U object, but let's just see exactly why. If you go to the U object inside the documentation, and then we were to click the 2000 odd derived classes and dock that on the left, what you'll realize is that the collapsed view in the class hierarchy is a subset of these 2000 classes. Actor corresponds to actor, then you get actor component, skipping a couple, actor factory here, and so on. All right, they're all prefixed U if they are ultimately inheriting from U object, and then actor, which in turn inherits from U object, starts the A convention, and then it all goes A's under the actor. Okay, so we ultimately are dealing here with a static mesh component, and it's a U static mesh component because if you follow it up the tree, it inherits from U object, not from under A actor. It's one of these guys out here. All right, fine. So there's a little bit more about the class hierarchy, just helps you get some context. Now, the reason I've told you all that is because when we decide what we're going to put here, I want to just not take it for granted that the type is U static mesh component, because you may not know that you need to start with a U. You could just mash the keyboard with the word static mesh component, and it'll tell you it's a U, but that doesn't teach you anything. Now you know why it's U. So we're going to have a U static mesh component pointer called barrel, and we're going to be good and set it to the null pointer as a starting point. So there it is. We have something to set. Now, we're going to make ourselves a setter method. It's going to be a public setter method. I'm going to put it below the constructor, and I'm just going to say void set barrel reference, taking in the same thing, a U static mesh component pointer, and it's going to be called barrel to set. You'll see why I'm calling it like that in a moment. Okay, so let's go ahead and implement this setter for the barrel reference. The idea here is that we have a way of setting the barrel. If the tank aiming component is going to have a barrel member variable down here, then we shouldn't expose that publicly. It's generally bad practice, so we want to set a method. So there's our setter method. And now we're going to implement it. It's relatively simple. It's a lot of messing around, but once it's done, it's done. So let's do this maybe under the constructor here. We, of course, need to prefix this with the fact that the class is this, and then just put some code in. So now we have a barrel, right? It's called barrel, so we're going to say barrel equals barrel to set. And that is why I named this variable barrel to set. Otherwise, it would shadow the name of this variable, and we wouldn't be entirely clear what's going on. We don't want to be saying barrel equals barrel. We could say this barrel equals barrel and call this I don't like that. Let's just be explicit about it. Barrel to set. That's what we're actually doing here. Cool. So let's make sure this compiles. It's not going to do anything right now because nothing's calling this method, but at least we have a way, at least we have what I'd call a snowball's chance in hell of setting the barrel reference inside the aiming component now that we've got a setter all, well, set up, really. And of course, you've guessed it, we're actually going to set this barrel reference on the tank. Ultimately, we want to be doing this on the tank's event graph, and we're going to delegate it down to the aiming component. So we have the setter here now. It all compiles, and that's good. So now let's move our attention over to the tank and think about what the setter would look like on the tank. So it's also public. So we're going to go void, and we're going to call it set barrel reference. And we're going to do the same thing again. It's going to be a uStatic mesh component. And this is one of the dark sides of building things up through composition rather than inheritance, is we have to rewrite some code. But I think it's worth it. Barrel to set. Okay, so there you go. That's the declaration of that up at the tank. Now, at the tank, it's not just going to be a method that C++ is going to call. It's going to be a U function. Why function? Because it's a method. U properties for properties, functions for functions or methods. All right, so it's going to be a U function. Actually, the semicolon doesn't work on the end here. Strangely, you need to be careful with these macros. Sometimes it doesn't work. It does break U functions putting semicolons on the end. So it's a U function, and what's it going to be? It's going to be something called blueprint callable. And we may as well give it a category. I think it's the setup, really, because we're setting up the tank. So this is going to make a method that we can actually call from blueprint called setBarrelReference. What we're going to do over in the tank blueprint is, in its event graph on begin play, we're going to make ourselves a method that says setBarrelReference. We'll take the barrel reference from our component list, either from the component tab or the My Blueprint component list under variables, and we'll be feeding both the event play execution pin and the barrel reference into this method that we're about to make. All right, so that's the purpose of what we're doing. I'm just going to save everything here before I leave. Unreal's crashed on me a couple of times recently. I'm a bit nervous. So that's what blueprint callable does. It means it's a method we can actually call from blueprint, which is cool. So we're going to call this setter from blueprint. Right, so having done that, we now need to just implement that setter and actually just delegate it straight out from the tank. Why don't you do that? You've heard me talking long enough. It's very easy for you to go into zombie mode now and just copy what I'm doing. Why don't you pause the video and implement the set barrel reference method inside the tank CPP for me. I won't put a challenge slide up for this one. I just want you to do that. It's pretty simple. I'm not going to carry on till you've had a go at it. And I can tell whether you had a go at it, by the way. It's technology you wouldn't even believe. See through your screen right now. Okay. I'm going to trust that you've had a go at it. I can't really tell that you've had a go at it. You don't need to be covering your webcams with sticky tape. Although it might be a good idea from the other authorities' point of view. Okay, there we go. So there it is. And all we're going to do is we already have a tank aiming component. And that tank aiming component now has a method on it called setBarrelReference. And we're just going to pass through the barrel to set. How boring, right? But we've delegated out the barrel to set to the tank aiming component. Cool. All right, let's compile this up, and then the blueprint should have this function available to it. And then we can just do a quick log to make sure we've actually got the barrel's location, and we've actually achieved what we set out to achieve, which is getting the start location of our projectile's flight. And at the same time, of course, we're setting up a nice soft referenced asset architecture. Cool. So on begin play in the tank blueprint, do we now have a set barrel reference? We do. Yeah, that's the blueprint callable method that we made. There it is. Awesome. And we've got this pin here saying barrel to set, and it wants a static mesh component reference. Well, there you go. That's the barrel, and that's soft coded in blueprint. Aren't we happy? So let's compile this. I'm going to save it, and I'm going to save everything actually, and then just play. Now nothing should happen because all we've done is hopefully got that barrel reference through to the tank aiming component. But what I want to do now is go to the tank aiming component, and I want you to change this log so that it tells us that it's got a barrel, and ideally tells us the location of that barrel. So let's just change this log to say something more useful, like the tank name aiming at this position from, and then some other position. And that other position should be barrel location. I'm not going to do it all for you. I'm just going to get it going. Like so. And then what I want you to do here is write an auto barrel location, which now uses what we've done to get the location of the barrel. Go ahead, pause the video, see if you can find that barrel location and log it out now. You are pausing the video, right, even without the challenge slide up? Just making sure you're listening. It's not always about seeing those challenge slides. Okay, so can we get this barrel location this way? Well, we have a barrel local member variable, don't we? I hope. Let's just double check. There it is. Okay, so we've got a barrel there. Now, how do we get the component location? That was your challenge, really. Could you manage to find that? Let's see what this does. If you looked for get location, then depending on the quality of your autocomplete, you may have been lucky enough to find this get component location. You don't want the one prefix with exec k2, but there's one down here, get component location. All right. And then now let's see what type that returns before we try and log out a string that may not be. That's auto will tell us. It's a F vector. So to log that out, we're going to need to do a .toString. And then if you did all that, congratulations, because that should now log the starting and the ending position for all of the tanks. Let's go try it, and then we can congratulate ourselves that we have all that we need to calculate the full arc of the projectile's flight. And a relatively cool architecture. C note reference 45. Okay, I'm not going to read all that initially. I'm just going to look at line 45 and see what I've stuffed. What have I stuffed? Okay, I need to dereference, well, effectively do the contents at operator on the barrel location because of the quirks of the macro. So well done if you spotted that the first time. And well done not poring over that error message too long the first time, right? It's just not worth it. You can start to use your experience to not bother. Just take a look at the line of code, see what's obviously wrong, because that error message will keep you awake at night. Okay, oh, look at this. Now this is pretty cool. So that looks like it's feasible. Let's pause it for a moment, look at some of these values, and then just take a look at the locations of these tanks, and this will tell you whether they're in roughly the right place. So this tank here, one of these AI tanks, is at 4,400 by minus 2,300 by 100. So yeah, that's this guy here, isn't it? The barrel's not in exactly the same location. It's a bit higher and it's a bit different in X. Let's just take one more tank to check the feasibility, maybe this guy on the right. So this one, we can even look at the world outliner. This is tank BP569. So if we look at 569's log, its position is 5894. Yeah, it's close enough that you can see that that's working. Awesome. We now have the start position available to us in our tank aiming component, and we've got a chance now of actually doing the ballistic calculation. So congratulations, pat yourself on the back, and I'll see you soon.